So in this problem we have to find the Thevenin equivalent of the given circuit. So first of all, when we find the Thevenin equivalent of any circuit, we need VTh and RTh. So in order to calculate the VTh, which will be the open circuit voltage across the terminals A and B, we have to first look into the circuits whether we have any independent source available or not. As we can observe this particular circuit, that there is no independent source, whether we may be talking about independent voltage source or independent current source. Both of the sources are not available in this particular circuit. So we can say that due to the absence of independent energy source, the value of this particular current I will be 0. So there will be no current flowing through this branch, and due to this particular dependent source, current dependent voltage source, will also yield a value of 0. So in this case, the open circuit voltage, means the voltage VAB across the terminals A and B, will be 0. So VTh for this particular case will be 0. So now we want to calculate the value of RTh. This is the calculation for VTh. Now for RTh, what we can do is that, as we have a dependent source available in the circuit, so directly we can't calculate the resistances. So what we have to do is we can apply a test source across the circuit, and then we can calculate the RTh. So in this particular case, as we have a branch of 12 ohm resistor is there across, and we have a variable I with us. So across these terminals, here we have 12 ohm, 6 ohm, 4 ohm. So this particular current I is flowing. So because the value of this source is depending on this current I, so I will take a test source like that, so that we can easily calculate the value of I. And then, as we need, this will be the current IS due to this source. So when we will be calculating RTh, so voltage is already with us, Vs by Is. So Vs is already with us, which is 12 volt. So we need to calculate the value of Is. So as this source 12 volt is parallel to the 12 ohm resistor, so easily we can say that the value of I for this particular case is 12 by 12 is 1 amperes, and so this source 8I will also result in 8 volts. So now to calculate Is, we can directly apply KCL here. So basically what we can do is that Is, and then so here the value of Is will be, we are applying as KVL here. So we can see that 12 by 12 and 12 by 6 for this branch current, and then 12 minus 8, as we have already calculated this voltage, by 4. So it will come to 4 amperes. So now we can easily calculate the value of RTh. It will be 12 by 4 from this particular equation. So it will yield to be 3 ohms. So for this particular case, we will be having VTh will be 0 volt and RTh will be 3 ohms. So guys, the things to keep in mind is that the calculation of VTh, sometimes in exams it may come like that there will be no independent source available in the circuit. So in this case, you have to check the value of VTH. As here there is no independent source available, so the current I which will be flowing will be 0. So because of that, we have this open circuit voltage, or this VTH is 0 volt with us. So this is a thing to keep in mind, that how a question may be twisted.